Well, I was discussing about different types of higher order constructs. The first type is reflective reflective. It means when you have some theory or some literature that is basically providing evidence that the constructs have some common concept that should be measured separately, and you believe that a concept might have some dimensions like HOC. Higher order constructs might be measured by some lower order constructs like these three. In my case, in my paper that I have shared over here, just a minute. This was the paper that I have sent for publication and it is under review. Just a minute. And yes, this one. Uh, in this model, you can also see here, I would like to consider DIC. What do I mean by DIC? DIC is basically dynamic innovation capability. And I have some references that it is measured by market innovation, organizational innovation, product innovation, and process innovation. So DIC is the main constructs or the second order constructs, which is measured by these four constructs. So this model is basically DIC, dynamic innovation capability, which is measured by these four dimensions. So these are the lower order constructs, and this is the second order or higher order constructs. And then IWB is basically innovative work behavior. Yes, this one. Innovative work behavior is basically also a second order construct, and it is measured by exploration of idea, generation of idea, promotion of idea, and implementation of idea. So this is also a second order constructs. Then there is bank performance, which is also a second order constructs, which is measured by market performance and innovative performance. So this is how I have developed this model: market performance and innovative performance, that is bank performance. So this is how I have created this model. You can also see this model is a reflective model because the direction of arrow is towards their lower order constructs. So according to Hare et al, the type 1 category is reflective reflective. You can construct if you believe that your indicator causing your lower order constructs and your lower orders are causing your higher order constructs, you need to use the type 1, which is reflective reflective. Then there is a type 2, which is reflective formative. It means your lower order constructs are reflective, but your higher order constructs is formative. It means that your lower order constructs are basically caused by your indicators, while your higher order constructs is defined by these three lower order constructs. So when your dimensions define your main constructs, it means you need to use formative in higher order constructs and you need to use reflective in lower order constructs. In the same way, if you are using third type, which is formative reflective, in this case your lower order constructs are formative. It means these three indicators are defining your first lower order constructs, these three indicators are defining your second lower order constructs, and these three indicators are defining your third order constructs, and these three lower order constructs are causing your higher order constructs. Then there is a formative type of higher order, in which lower order constructs are formative as well as higher order constructs are formative. It means that lower order constructs are defined by these indicators and higher order constructs are defined by these three dimensions. So you need to understand, if I need to measure my major constructs, these are measured by these dimensions, and these dimensions are measured by some indicators. In the same way, if I would like to measure IWB, which is innovative work behavior, it is measured by some dimensions, and those dimensions are measured by some indicators. In the same way, if I would like to measure the bank performance, it is measured by market performance and innovative performance, and these two dimensions are measured by some indicators. So when there are some dimensions that you need to consider, it means you are dealing with the higher order construct. So I will prepare this model here for your convenience. Let me explain this from here. We just need to consider all our variable, like in our model MKTI, then ORGI. Yes, this one, like this. You need to consider here. Then what is the next one? That is PRDI. PRDI, this one. You need to select here for your ease. Then what is the next one? That is PROI. You can consider here like this, PROI, and you can select them and adjust them on the upward side like this. Make it some attractive look like this. So these four dimensions are basically indicating or basically causing a concept which is known as dynamic innovation capability, DIC. So how can we make it? We just simply double click in the blank area and we need to write here DIC, click enter. A blank option will appear over here. Now what I need to do, I need to select the indicators all at once from here. Like from here. Yes. All the indicators you can see are being selected from the dimension also. You need to drag these indicator in your main constructs and you need to hide the indicators to make it simple. Then you need to connect them in a reflective mode, just like this. It is a reflective higher order construct. So it will look like this, just like this. And you can adjust it as per your ease or as and when do you like this. You can adjust the name of your dimensions as per your ease. All right. Now I need to see the bank performance is measured by MP and IP. I need to see here the MP and IP. This is MP, which is already here. And the second one is IP, IP1 to IP6. You just need to put it over here like this. Yes. and you can double click on the blank area, BNKPR, performance, bank performance. And we need to put these indicators also in their higher order constructs, just like this. Drag it and put it over here. And you just need to hide indicators and make them reflective constructs like this. Yes. Now you can see the constructs were established. So next thing I need to do is I need to include IWB, but first we need to connect DIC with this. Yes, now it is connected. So if we want to run the direct relationship, we can run it easily from here. But next thing, we need to consider the moderating variable also here. So for the purpose of including the moderating variable, what we need to have, IWB, which is measured by exploration of idea, generation of idea, promotion of idea, and implementation of idea. So we need to find out exploration of idea, which is here. You need to put it here, exploration of idea. For the purpose of convenience, we can hide indicators of all so that we can easily consider everything over here. We can create the model that looks like in our conceptual model like this. Yes, this one. You can also hide the indicators of these variables too. Then GI, which is generation of idea. You can hide its indicator too. Then PI is what? That is promotion of idea from PI1 to PI4. Hide indicators. And then II. What is II? That is implementation of idea from here. And hide the indicators. So these are the lower order constructs of innovative work behavior constructs, which is moderating over here. So in the blank area, I would double click and innovative work behavior. I need to create this and I need to put the indicators from EI1 to II4 from here to here, and I need to hide the indicators, and then I need to connect them in a reflective mode. Yes, you need to connect them in a reflective mode like this. So it is a complex model and you need to connect them like this. If you can see my model, I have also connected it with dependent variable, but it is not necessary. You conceptually it is connected, but when you run the regression, it will automatically run the relationship between IWB and bank performance. So you don't need to connect it. You just need to connect the relationship like this. So this is basically the higher order constructs. So how can we run it? If we does not consider the moderation in this level, let's suppose, uh, because in case of your you can say your measurement model, you don't need to connect the moderation. You just need to connect it like an independent variable in case of your moderation analysis, in case of your measurement model, sorry. So as I am going to run the measurement model, so I just need to connect like this, PLS algorithm, start calculation. It will take some time in case of bootstrapping because it is a very complex model. So you can see in case of outer loadings, here the outer loadings of your second LOCs are greater than 0.60, but some of these values are less than 0.70, but they are acceptable because 0.70 is the condition in case of indicators, not in case of lower order constructs. The lower order constructs should be greater than 0.40. So these lower order constructs are showing values greater than 0.40. There is a positive impact. You can also verify the construct's reliability and validity from here. There is only one issue, which is in case of AVE value, but we need to see the outer loadings values from here. You can see here there are some values which are less than 0.70, but as we have told you that in case of second order constructs, you need to see whether these values are greater than 0.40 or not. In case of indicator, your values should be greater than 0.70 as per here at all. Here you can see E1, E2, these values are greater than 0.70. Even 0.60 greater than 0.60 is also acceptable in some cases. So in case of your second order constructs, these values should be greater than 0.40. So these values are also good. So we can see here there is no issue found in case of your outer loading constructs. We can hardly see any value which is less than 0.40. There are some value which are less than 0.50. So maybe we need to delete those values, and we need to see the discriminant validity. There are a lot of values which are greater than 0.90. So we need to consider revising our constructs, and we need to consider uh, some of the statement. We need to revise some of the statement. We need to increase the sample size in order to remove this issue. We can see the Fornell Orcutt criteria. The first value, the remaining value should be less than this, but you can see there are a lot of values which are greater from the first value. So these criteria also showing that there is an issue of discriminant validity over here. So we can also see the cross loading, and it will indicate the similar things that we will find over here, like in case of E1. You need to see there are a lot of values which are repeating in other constructs too. So there is an issue of discriminant validity in this case. We need to see the VIF values. VIF values are fine, they are less than 5. But in order to see, I have a doubt whether there is a CMB issue, but it shows there is no CMB issue, which means basically the common method biases. So there is no issue of common method biases in our data set. So we just need to revise our data set in terms of sample size. We need to increase the sample size because there is no common method biases find out over here. We need to see the model fit, and it is slightly greater than our required level. Our required level is 0.08, which is slightly greater than this. So these are the things. Then we need to see the R square. As we have multiple indicators, our main dependent variable is showing an R square of 0.81, which is indicating that 81.9% of independent variables are explaining this model. Then you can see the R square of other indicators too. Then you can see the F square. F square is also good because it is indicating that model is good. Then you need to see the predictive relevance that you can find out from here through predictive PLS. Start calculation. If we are lucky, it will run the predictive relevance too. You need to see it. I will show you the interpreted file from my article, because I have corrected the data, because this was the paper I have worked 2 years ago, and this paper is still under review because it has gone third revision till date. And there are some issue in terms of literature evidence and so on. So we need to see the prediction, the model prediction, and we just need to see the first column, and the values are greater than 0. You can see here the values are greater than 0 in the overwear, in the prediction error, and in case of PLS descriptive LV prediction summary. This table is basically relevant for us. You can use this table because it is showing the indicator wise, or it is showing the construct wise the prediction. So these value Q square predict should be greater than 0. So you can see here these values are greater than 0. It means that our dependent variable is basically a good predictive ability. Our dependent variable has a good predictive ability, as well as other constructs have a good predictive ability. Now we would like to run the moderating impact. So you need to connect it like this. You need to delete this sign and you need to run it. It will take some time because it is a very complex model, and we need to run the bias corrected and accelerated bootstrap two tail. So just start calculation and you will see the results. You need to wait, and it will take some minutes or it will take some time. Till then, if you have any question regarding the higher order constructs, you can ask. And before the procedure is complete, I will show you the corrected version or corrected results of my file. This was the demographic summary. This was a model that I have run, but it has some of the issues within it. You can see the VIF values, the factor loading value, the VIF values. And this is Cronbach alpha composite reliability, AVE. I need to include the mean and standard deviation in these results. These are the Forner-Larker criteria, and you can see here the results are good because I have changed the data set. I will find out where the correct data set is located, but these values are good because these values are estimated after making correction in the data set. Like I have increased the sample size, and I have made corrections in my data set. This is HTMT ratio, which indicates the values less than 0.90. So these values you can see here, all these values are less than 0.90. The model fit is also very good. You can see here the results. The SR MR results are less than 0.08. So the model fit is also very good, and NFI also increase in my revised estimate. And this is the effect size and coefficient determination. You can see the values over here. This is F square, which is effect size. So F square or effect size basically indicate how much effect a particular variable has in your study. That is why we have considered the F square. So in case of bank performance, we have the R square 82.5%. And because this was the dependent variable, we does not consider the effect size of the dependent variable. We can consider the effect size of our independent variable. So dynamic innovation capability was our independent variable. So why its R square is showing 1.000? Because we have some indicators over here in our model. We have made this as a second order model. So that's why this is basically the R square of its second order constructs, the lower order constructs. So you need to ignore these R square values for your independent variable. You need to concentrate on the R square value of your dependent variable only. So as a independent variable, it is showing a medium effect size, which is 0.339. Then you can see innovative performance and market performance. They are showing effect size of medium size. Then you can see the innovative work behavior. It is showing a medium size effect. Then you can see the outer model here. And these are basically the hypothesis results over here. This is moderating impact. I might have included Q square value over here. I will show you. Maybe in some other file, it may be in some other version too. Let me open other file. I will see maybe in this file. No, it is not in here. I need to see. I think this was the version that I have shared in 2021 during COVID season. This was the paper I have written during COVID, and I have worked a lot on this paper. Around 2 years ago, I have run this model. Yes, this is basically the table I was searching for. You can see here the Q square, which is predictive relevance. You can see the F square effect size. It is basically the revised version of our model. You can see here the effect sizes of different indicators, and you can see here the predictive relevance. So in case of dynamic innovation capabilities, the predictive relevance is very high. In case of innovative performance, the predictive relevance is very high. In case of innovative work behavior and bank performance, the predictive relevance is very high. So these are all the things that I have considered over here. Here is basically the interpretation. Table 4.6 reports the estimated score of F square, Q square, and R square respectively. The effect size or F square is the degree of defect independent of size of its Meyer, according to Cohen. These are basically references which are used when you are going to interpret effect size or F square. The effect size has a different interpretation as per the values ranging between a certain limited. According to Here et al. 2016, F score less than 0.02 is known as zero effect. So if your F square score is less than 0.02, it means there is no effect or zero effect. If F square score between 0.02 to 0.15, this is known as small effect. And if F square score between 0.15 to 0.35, this is known as medium effect. And if F square score is greater than 0.35, sorry, this is 0.35, then this score is known as large effect. So you can see here effect size. These are the effect. This is zero effect. This is large effect. This is zero effect. This is large effect. Here you can also see this is perhaps the small effect, large effect, large effect. So these are how you can interpret the values. Then in case of Q square is used as a criterion for assessing the predictive relevance for a large or complex PLS model. In our case, our model is complex because it involves the higher order constructs as well as moderation impact. So Q score values, if it is less than 0 or equal to 0, it indicates that estimated model does not have predictive relevance. However, if Q score is greater than 0, it indicates that estimated model has a predictive relevance. So you simply can see here the model has values greater than 0. So it is predictive relevance and it has greater pre predictive relevance. So this is how you can find out your model. It is still running because model is very complex. So we can interpret the other things. I would suggest all the participants to read this paper. This is a very good paper, how to specify, estimate, and validate higher order constructs. I have simply, for your point of simplification, I have run the first type, reflective. You may run the reflective formative. If you find some evidence that your dimensions of your main constructs are basically defining your main constructs. It means if your second order construct is basically defined by its dimension, you can use reflective formative constructs. In the same way, if your low order constructs or your dimensions are basically defined by indicators, but these three indicators, these three low order constructs basically cause your higher order constructs, then you can use formative reflective. And if you have evidence in literature or from theory that your low order constructs are basically defined by indicators, and then your uh, you can say low order constructs define your higher order constructs, then you need to use formative. uh, as per your ease, I would like to show from here that you may understand what I am trying to say. Just a minute. For example, these are the definitions. If I believe that, if I have some evidence that these four are the dimensions of dynamic innovation capabilities, and these four basically define dynamic innovation capability, then I need to use formative constructs. But if I have evidence that these four basically cause the dynamic innovation capability, then I need to use reflective constructs. So this is basically the idea that you need to understand. And I have basically guide you regarding the whole idea in my previous session, that how we can assess whether we need to use our reflective constructs or formative constructs. So I think you may have a basic understanding. If you skip my previous session, you need to see the recording where I have told you in clearly that you need to whenever you need to use the reflective constructs and whenever you need to use the uh, basically the formative constructs. So you need to understand it is still running because it will take some time. The model is complex. If your model is complex, it will take some minutes, or even it can take some hours, but it is showing that it will require 449 hours, more than 400 seconds, sorry, more than 400 second it will take. During this period we can discuss some other things, like the last thing that after this estimation is done, I will discuss about CBSEM. CBSEM is basically covariance based structural equation modeling. When your data set is large, it means you have greater than 30 observation, your data set is normal. You have some theory in the background that you need to test, or you need to extend the theory, or you need to verify the theory, and your data set is normal, it is fulfilling the assumption of normality, you need to use the CBSEM. It is basically a technique which is backed by MS software. This is a software of SPSS, but we can use this function in Smart PLS also. So after the analysis is complete, I will show you how you can run the CBSEM procedure using the Smart PLS. So it will take more than 300 seconds too. So we will discuss some other consideration. The estimation procedure is same. Like you need to consider the measurement model, you need to consider the structural model, you need to consider the moderation analysis, you need to consider the mediation analysis. The only difference is basically the covariance based technique, as well as you will see a very large model fit table in case of CBSEM. In case of PLSM, you will see a very short table of model fit. Like in this case, you can see here a very short model fit table. I would like to show you. This is basically model fit indices when you are using uh, Smart PLS SEM. Here the indication is that SRMR value should be less than 0.08. So these values are less than 0.08. As well as there are some other values over here, like NFI should be close to 1, or it should be near to 1 or close to 1 or greater than 0.90. So we can see here, and we need to see how much seconds are remaining. It is still more than 250 seconds here. It will need to run. There is less than 1 minute in our session time. So you need to join again using the same link. So we can complete the second part, which is higher order construction, as well as the CBSEM. These are basically the remaining part. We have discussed in detail the higher order constructs. I have told you how to use it. And the only thing which is remained over here is the estimation, which is still running over here. So we will see the result.